Okay, picking up with problem number 32. That's it right here. It's kind of hard to see what's at the top. 32, the graph is a graph of the function f of x equals x squared minus 4x. And they want me to determine where this is increasing, decreasing, or constant. And I have this point here at the bottom that's a minimum point. So from negative infinity until it gets to 2, this function is decreasing. So decreasing, whoa, that again, decreasing from negative infinity to 2, and then increasing, my y values are going up as I move from 2 to infinity. And increasing, decreasing, constant always gets parentheses, no brackets, because it's over an interval. It's increasing between 2 and infinity, not at 2. It's not increasing at a point. It's increasing over an interval. Whoa, 34. 34, let me erase this and move this. All right, 34, we have this graph, the square root of x minus 1. It is decreasing as I move from negative infinity to negative 1. So decreasing from negative infinity to negative 1. And then as I move from 1 towards infinity, it is increasing from 1 to infinity. Again, parentheses on both sides because it's over an interval. Problem 36. Got a different looking graph here. It is increasing. This point right here is negative 1, negative 1. So it is increasing from negative infinity to negative 1, and then it's decreasing between negative 1 and 0. So it's going up until I get to negative 1, then it's going down between negative 1 and 0, and then from 0 to infinity it's also increasing. So I'm going to put a U because that's my symbol for and from 0 to infinity it's increasing. Increasing here, decreasing, and then increasing. Alright, 38 is kind of hard to see. Let me see if I can scroll this down a little bit. Oh, here we go. Move this down. Okay, it is increasing as I move from negative infinity to negative 2. Let me write that down. Increasing from negative infinity to negative 2. Then it's decreasing from negative 2 to this point right here is negative 1. If you look at this graph, it's hard to see the way I took this picture, but on the bottom here it said x plus 1. That means there is an asymptote at negative 1, because if you solve that for 0. So there's like this vertical line going up and down. So between negative 2 and negative 1, this function is decreasing. And then it's going to go down again from negative 1 to 0. So it's like here it's going from negative 2 to almost negative 1 down. And then it's going to go down again from the other side of negative 1 until I get to 0. And then it's going up from 0 to infinity. And that is problem 38. 40, they want me to use a graphing utility. So I'm back to my calculator now. In 40, they want me to graph just y equals x and tell them when it's increasing. Clear out what's there. Y equals x. It says determine the intervals over which the function is increasing, decreasing, or constant, and make a table of values to verify whether the function is increasing, decreasing, or constant over the interval that you indicated or identified. If you take a look at this graph, looks to me like this is increasing all the time. So I would write down for my answer, maybe it's not writing, that it's increasing. Not letting me write. It is increasing from negative infinity to positive infinity. That would be my answer. Let me see if I can make a page here. For number 40, I would say that it's increasing from negative infinity to positive infinity. They asked me to make a table. I'm just going to look at the table and see if that verifies it. And you can only look so far. You can't go to infinity. But if you look at the table on your calculator, second graph, it looks like it's going up and up and up and up as I get bigger and bigger and bigger. And if I go down, it would get smaller and smaller. So as I'm moving from negative infinity to positive infinity, the y values go up. So that seems to support that. All right, 42, y equals x squared minus 4. This is a parabola, so it's decreasing part of the time and then increasing. Let me find this point. I think it's 0, -4, but let's verify that. And obviously, if you remember transformations last year, x squared minus 4 takes your parent function x squared and moves it down 4 units, if you recall that. But if you want to just check, this minimum value is at, I made a left bound and a right bound, and it's at 0, -4. Whenever you see, I'm glad this did this, whenever you see something, a number and then e negative, and it's a larger number like -7, that's really 0, because what that number is it's point 0, 0, 0, 0, 0, let's see, 6 zeros and then a 4. So it's just a rounding error. The calculator is trying to come up with where this hit, and it just got rounded off a little bit. You would all know if it said 3.999 that it was really 4. It's the same thing here. If you see something like this, this is really 0. So this minimum point is 0, -4. So in this case, the graph is decreasing, and it won't let me write. I'm going to have to write it on that other screen. Decreasing from -infinity to 0, and increasing from 0 to infinity. So 42 is decreasing from -infinity to 0. It's a terrible looking infinity. And increasing from 0 to infinity. All right, back for 44. Y equals 3x to the 4th minus 6x squared. 3x to the 4th minus 6x squared. And I'm going to graph that and take a look at it. And I get, so I have a decreasing, and then it increases, and then it decreases again, and then it increases. And this point appears to me to be -1, -3. Let me just verify. If it is, and I can tell that it's symmetric, let me make a minimum point over here and see if it's at -1, -3. Left bound and right bound is symmetric, so it'd be the same thing on the other side. Hopefully it's 1, -3 over there. This appears to be, see how it says -0.999? That's really -1, -3. If you're not really sure, you can also check your table, which I need to tell the table to start at. Let's make the table start at 0. Go to -1, and you'll see it is -1, -3, and 1, -3. It's just a rounding thing on this calculator. Okay, so here's what it's doing. It's decreasing from -infinity to -1. So write that down. So 44. It is decreasing from -infinity to -1. Then it's, let's look at the graph, increasing between -1 and 0. -1 to 0. And then it's decreasing again from 0 to 1. And it's increasing again from 1 to infinity. Alright, that's 44. Let's see if I can get 46 in right quick. I'm going to keep going. 46 is x times the square root of x plus 3. X square root of x plus 3. Graph it. And all of this that I'm doing, we haven't been looking at the table, but the table should verify it. Okay, so this is going down from here to here. So let's see if that point is -3, 0. Doesn't look like it hits it, but I think it might. Yep, it really does hit it. It's hard with square roots. It tries not to get too close. So this is really starting at -3, 0, and it's going down here. It's connected. So it's going down to that middle point. So second trace, I need the minimum point there. Oh, I didn't make a left bound. It's going to tell me there's an error. Let me try it again. Second trace, I need a minimum. Got to give it a left bound. So So I'm going to the left of that low point, and then I need a right bound to kind of slice out a portion of the graph and say, hey, find a minimum in between these two. And it says guess. I hit enter one more time. It tells me there's a minimum of -2 when x is -2. So this graph is decreasing from -3 to -2, and then it's increasing from -2 to infinity. So 46 decreasing from -3 to -2, and increasing from -2 to infinity. I am over 10 minutes, so I'm going to go ahead and stop, and I'll pick up with 48 on the next one.